Hello, today we are starting Hands-On Equation Lesson 4, and you are going to learn about another legal move that you can make. Last time you learned that you can remove a pawn from both sides as long as it's balanced. If you take one pawn from the left side, you need to take one pawn from the right side. If you take two pawns from the right side, you need to take two pawns from the left side. Today's new rule is that you can remove the same value from both sides. So if you have a die on one side that's a 2 and a die on the other side that's a 2, you can remove both of them. So here we have the problem 4x plus 2 equals 3x plus 9. So I'm going to go ahead and build this problem on my balance. Here's 4x's plus 2 equals 3x's plus 9. Okay, so now, remembering back to yesterday's rule, you can take a pawn from both sides. You could take two pawns from both sides. You can take three pawns from both sides. Now, I can't take four pawns from both sides because there's only three pawns here. So I can only take three pawns from this side and three pawns from this side. So now my new equation is x plus 2 equals 9. So the new part about today's lesson, the new rule, is that you can remove numbers that have the same value. So I can't take away 9 from both sides because both sides does not have 9. I can, however, take 2 away from both sides. If I take 2 away from this side, then I take 2 away from the 9, it will turn into a 7. So now I have x equals 7. So now it's time for my check. So I believe that x equals 7. So now I am going to plug in 7 for all of these x's. In other words, I am going to make all of the pawns into 7s, and we're going to see if each side equals out. So here on the left side I have 7 plus 7 plus 7 plus 7 plus 2. 7 plus 7 is 14, doubled is 28, plus 2 more is 30. So 7 plus 7 plus 7 plus 7 plus 2 equals 30. Remember, this middle part is the equal sign. So let's see if this side balances out. So up here I have 3 7s, 7, 14, 21, plus this 9, so 7 plus 7 plus 7 plus 9. Again, I just turned all these pawns into 7s. So 7 plus 7 plus 7 plus 9 equals 30. So with x equaling 7, 30 equals 30. That's my check. So I know that x must equal 7. So now we have another example to look at. This is x plus 2 plus 2x equals x plus 12. So let's go ahead and set this problem up. X plus 2 plus 2x equals x plus 12. So for 12, the easiest way to show 12 is to add a 10 and a 2. X plus 2 plus 2x equals x plus 12. Now let's see what I can remove from both sides. So I can see right away there's a pawn on both sides, so I'm just going to remove one pawn from each side. I still have two pawns left over here. but I can't remove them because there's no pawns over here. Something I can remove is a 2. I see a 2 here and a 2 here. I can remove both of them and they will cancel each other out. So now I have x plus x equals 10. So I'm thinking what plus itself equals 10. If you're thinking 5, you're thinking the same thing I am. We believe that x equals 5. But now let's go back to that original problem and see if our check works. So let me build it again. X plus 2 plus 2x equals x plus 12. So there's the original problem, and I'm going to turn all these pawns into 5s now to see if our balance stays balanced. So 5 plus 2 plus 5 plus 5. I turned all these blue pawns into 5s. 5, 10, 15, 16, 17. So this side equals 17. Now let's add up this side. 5 plus 10 is 15 plus 2 more equals 17. So now we believe 17 equals 17. That is our check. So that proves that x must equal 5. Here is what an example looks like on paper, and we're going to be practicing the rule from the last video. 5x equals 3x plus 10. So I remember I can take a pawn away from both sides. I can take 2 pawns away from both sides, and I can take 3 pawns away from both sides. I can take 3 pawns from here and 3 pawns from here. I can't take 4 pawns from both sides because this side only has 3 pawns or 3 x's, and both sides need to stay balanced. So let me show you how I would take 3 x's from both sides. Minus 3 x's here, minus 3 x's here. I'm keeping everything neat and lined up. I'm thinking of this as a giant subtraction problem, and I'm going to bring my equal sign down. So now I have 5x minus 3x. Well, 5 minus 3 is 2. So I have 2 x's left. My equal sign moves down. 3x minus 3x. Well, that's 0 x's. It just kind of cancels each other out. Then I have a positive 10 over here. So I just have 10. So now my new equation is 2x equals 10, or x plus x equals 10. Well, x, in the same problem, the x always has to have the same value. So what plus what equals 10? I'm thinking 5. I'm thinking that x equals 5. So let's check our work on that. Let's see if it works out. I'm going to plug in this 5 into all the x's up here. So 5 x's. Well, 5 x's, 5 times 5 is 25 equals 3 x's. Well, if 1 x is 5, 2 x's is 10, so 3 x's is worth 15 plus 10. So 15 plus 10 equals 25, and this side is equal to 25. Both sides equal out to 25, so we know that our correct answer is x equals 5. Our check worked out and kept everything balanced. This problem looks really scary, but if we take both of our rules and we put them together, we can make this problem nice and easy. So let's give it a try. We have x plus 2x plus 14 equals 5x plus 2. So I can combine these x's in my head. I know that x plus 2x is 3 x's, and I have 5 x's over here. So I am going to take the x's away from both sides. This side, I'm going to do minus 3x. I'm going to take away this one and these two. And over here, I'm going to take 3 of these x's away, minus 3x. Think of this as a giant subtraction problem. So now, I got rid of this, I got rid of this, and I have 14 equals 3x minus 5x minus 3x equals 2x plus 2. So now I have a new equation, 14 equals 2x plus 2. That still doesn't bring us to our answer. What does x equal? So let's think, what else can I take away from both sides? I can take 2 away from both sides. I can take this 2 away and 2 away from the 14. So I'm making another subtraction problem, minus 2, minus 2. We'll bring our equal sign down. 14 minus 2 is 12, and 2x comes down, and positive 2 minus 2 equals 0. So these really just cancel each other out. So now I'm left with 12 equals 2x, or 2x equals 12. It's the same thing either way. So if 2x equals 12, then 1x must equal 6. But we have to check. So we are going to plug in 6 to all of these x's. So I'm going to rewrite the equation, and I'm going to take all the x's out and put 6's in. 6 plus 2 x's is the same as 2 times 6. 2 times 6 plus 14 equals, well, 5 x's is the same as 5 times 6. 5 times 6. I'm using this dot right in the middle as my multiplication sign, because if I made it look like an x, you wouldn't know what an x was and what was being multiplied. Adding 2 right over here, plus 2. So now, remembering PEMDAS, we need to do the multiplication first. So 2 times 6 is 12, plus 6 more is 18, and plus 14, we have 18 and 14. So here we have 12, 32 on this side, and 5 times 6, 5 times 6 on this side is 30, plus 2 more is 32. I know that 32 equals 32, so x must equal 6. Now it's your turn to try a few problems like this on your own.